Bismillahirrahmanirrahim. Today we will discuss the covalent radii. As we have discussed already that atom is not isolated. Atom of an element is always in combination with the other atoms. Therefore, we cannot take the size of a single atom. We have to calculate the atomic side in terms of atomic radii, covalent radii, and ionic radii depending upon the environment of the atom. If an atom is bonded with another atom making a covalent bond, then in order to calculate the size of atom, then we will have to discuss it by taking its covalent radii. Now, what is covalent radii? It is half of the distance between the nuclei of two similar atoms of same molecules which are bonded together through a single covalent bond. Let's suppose this is a hypothetical molecule in which A and B are two atoms. Both atoms are same. When they combine together to form a single covalent bond, then the distance between the nuclei of A and that of B is called bond length or bond distance. So if we take half of the distance between the nuclei of two bonded atoms, then it is said to be the covalent radius. Let's take some example of diatomic molecule. For example, hydrogen, bromine, chlorine, iodine, and fluorine. All these atoms are molecules of element, and in all these examples, same atoms are combined together through single covalent bonds. Now, these are some diatomic molecules: the halogens, fluorine, bromine, chlorine, and iodine. If you look at the bond length or the distance between the nuclei of two fluorine, it is 143 picometer. So if we take half of the distance between the two nuclei of fluorine, then it is equal to 72. So the covalent radii of fluorine, of one fluorine, is 72 picometer. Similarly, bromine, the distance between the nuclei of two fluorine atom is 228 picometer. If we take half of the distance, which is equal to the covalent radius of one fluorine, then it is equal to 114 picometer. There is another example, the halogen. In the halogen series, chlorine molecule, whose bond length is 198. So the covalent radius of chlorine is 99 picometer. Similarly, iodine, the covalent radius of iodine is 133, which is half of the distance between the nuclei of two iodine atoms. There is another interesting factor that if we look at periodic table, and if we move from fluorine, chlorine, bromine, and iodine, so as we move from top to bottom, atomic size gradually increases, and hence covalent radii also increases. So the covalent radii also depend upon the atomic size of an element. The trend of covalent radii is similar to the atomic radii. It increase when we move from decrease when we move from left to right, and it increase when we move from top to bottom in periodic table. So the atomic size of an atom is expressed either in atomic radii, the covalent radii, the ionic radii. So that's all. It is all about the covalent radii according to the scope of the book. Assalamu alaikum and have a nice day.